Okay, so here we have our first video for chapter 3, basically dealing with trigonometry. This is section 3.1, all right? 3.1, if that helps up here, talking about angles and their measure, okay? Before we jump into this, we've got to make sure that you understand what a Cartesian coordinate system is. We basically call it the XY axis, okay? Invented by, or created by a guy named René Descartes in the 17th century. The development of this idea here, the fact that we can put a grid on things, was instrumental in the joining of algebra and trigonometry. All of a sudden, it just really helped advance the idea of mathematics in general. Okay, so the biggest thing is to understand that this is the x-axis. Hopefully you know that. This is the y-axis, the vertical, and the quadrants. There are 4 quadrants, right? So the x-y axis divides space into 4 quadrants. We call this the first one, the second, third, and fourth quadrant. This being the positive x-axis, right? This is positive x over here. This is negative x. This is positive y, and that's negative y down there. Okay. So we are going to jump into this and talk about angles in standard position. Now, an angle, basically, first of all, you understand, hopefully, that an angle is simply just 2 sides, right? Or 2 arms or 2 legs, whatever you want to call it, with an angle in between them. We often use theta, this Greek letter here, theta, to represent an angle, okay? We call this theta. It's like the x of angles, okay? Now, the arm that we start with, we call that the initial arm, and we call that the terminal arm. Now, if I gave you an XY, if I gave you an idea, or if I asked you where 0 degrees was, okay, in space, where would 0 degrees be? Let's say we're looking at an XY axis, 0 degrees. A lot of people would jump at north, okay, because if you look at a map, north is 0 degrees, okay? But since we are talking about a coordinate axis here, we make the positive x-axis 0 degrees, and we move this way. So that's 0, this is 90 degrees, that's 180 degrees, that's 270 degrees, and when we get back here again, that's 360 degrees, okay? So, first of all, angles in standard position, it's a positive angle between 0 degrees and 360 degrees, okay? With the initial arm on the positive x-axis, okay? The initial arm on the positive x-axis, and the vertex at the origin, this would be the vertex, right? The vertex is where the angle is, so we'll call this theta. This will be the initial arm, or side. I think they refer to it as a side in your book. And this is what they call the terminal arm, okay, where it ends. So your angle starts here and goes to here. That's where it ends, and we measure the angle in between. So when we go this way, that's a positive angle. If I had an angle down here and measured it this way, we call that a negative angle, okay? Lots of terminology going to be happening here. Hopefully we'll get it dialed by the end of this lesson, and if not, you can always rewatch it or come ask me some questions, okay? So now we're going to look at what we call, there we go, sorry, clockwise rotation. Okay, it gives a positive angle. Counterclockwise rotation, or sorry, counterclockwise is positive and clockwise is negative. Blah, 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 blah. Okay, so coterminal angles. All right, so coterminal means they have the same terminal, right? They end in the same place. So these are angles with the same terminal arm, okay? They are 1 full rotation away. So if I have an angle right in here, say that's 30 degrees, okay? I can find a coterminal angle by adding 1 full rotation, or 30 plus 360 is going to give me 390 degrees. I can also go the other way and subtract 30 degrees, 360 degrees, which would give me negative 330 degrees. So 30 degrees is equal to 30 degrees is equal to 390 degrees, which is equal to negative 330 degrees. These all refer to this angle right here, okay? It's all the same thing. Now, let's move on here. We're going to look at something that we call reference angles. These are probably the most important angle that you're going to be using when it comes to making your or solving your questions and answering the questions that you're given, okay, or solving any problems. Reference angles are the angle between the terminal arm and the closest x-axis, okay, and they're always less than 90 degrees. So I'm going to give you a couple diagrams here. We're going to start with this one right here. If I have an angle over here, just like this, we'll call that 150 degrees, okay? We know that's 0, that's 90, that's 180, that's 270. Well, what would be the angle between the terminal arm and the closest x-axis? Hoping you can see that that's going to be this right here. We'll call it theta r, okay? So your reference angle is the distance from your terminal arm to the closest x-axis. And if this is 150, I need 30 more degrees, okay, to give me 180 degrees. Now, how about if I went down here? Let's look at this one and say, okay, I went all the way around, and I'm going to call that 300 degrees. Okay, so all the way around to 300 degrees. This here would be my reference angle. And I know that this is also 360 degrees here. So from 300 to 360 is going to be 60 degrees in that case. All right. So let's have a look and see if I can make some sense of this for you. I'm going to draw 4 different little axes here. Okay. And if I put it here, I'm going to call this my theta r. Oh wait, this isn't going to work. Hold on a sec. That's not big enough. Let me make it a little bit bigger for you. Okay, let me just get a different piece of paper. There we go. So here we go. If I'm in here, this is my theta r, which is equal to your theta in standard position. It's the same thing, right? Now, if I am over here, this is my theta r, okay? And this is my theta in standard position. And we know that this is 180 degrees. So your reference angle here would be 180 degrees minus your standard position angle. Okay, so 180 minus this, so this is all 180 here, the whole way is 180. Take away this bit, it's going to give you a reference angle. Okay. Now, if you're down in the 3rd quadrant, let's make this my theta r, and then this whole thing is your standard position angle, right? So your reference angle now will be, well, if this is your standard position angle, you want to know this thing, you can take away 180. So your standard position minus 180 degrees will equal your reference angle in that case, okay? I might as well just have a look at the last one here, okay? If I have an angle in here, this will be my reference angle, and this will be my angle in standard position. So in this case, your reference angle, okay, will equal what? So this is 360. That's going to be less than 360. We want to find the difference. So it's going to be 360 degrees minus your angle in standard position. Okay, so that, ladies and gentlemen, is your reference angles. Okay, we're almost done here. Let's have a look at a couple other things. Here we have a picture of sort of a summary of everything here, okay? So we have 0 is, so theta is between 0 and 90 in the 1st quadrant. Theta is between 90 and 100 degrees in the 2nd quadrant. Theta is between 180 and 270 in the 3rd quadrant. And the angle, or theta, is 270 and 360 in this 4th quadrant, okay? So 0, 90, 180, 270, 360. We could also go the other way around, call this negative 90, negative 180, negative 270, negative 360. But we deal primarily with positive angles, okay? And now this is our summary again of what we were just showing you, that your reference angle is equal to your angle in standard position here because it's just the same, right? Over here, your reference angle is 180 minus your standard position angle. Third quadrant, your reference angle is your standard position angle minus 180. And in the fourth quadrant, it's your reference angle that is equal to 360 minus the angle in standard position. Okay, so there's a lot of stuff here, but look at it a few times, give it a shot. I'll give you a few questions pretty soon here, and then we can figure out a few things, or sort it out. Anyways. So the angle R, theta R is reference angle, theta SP is angle in standard position, okay? Just to give you a legend as to what these symbols represent. The last thing that I want to talk about before I give you some examples is reflections, okay? So I can ask you a bunch of questions with this. If we have an angle here like this, okay, if I gave you a 30-degree angle right here. First of all, you can see the reference angle is 30 degrees, right? If I asked for a coterminal angle, you'd add 360 or you'd subtract 360, okay? If I asked you to reflect this over the y-axis, so it's like putting a mirror here, and then, okay, that's going to be the same over there. Well, that means that angle is going to be the same too, right? How about if I ask you to reflect it over the x-axis? It's like putting a mirror here, and then you just have a line going down this way, where this would also be 30 degrees, right? Well, you can reflect it over the x and then over the y, which means you'd come down here and have the same angle as well. So all these have the same reference angle, and all these have very similar characteristics, okay? Here, let me just show you a prettier picture here. Now, if we look at this is a full revolution here, okay? If I have a point xy, this is the x value, that's the y value, right? And we can always find r by doing Pythagoras, right? So your x squared plus your y squared is equal to r squared. Now, if we reflected this over here, boom, what do you think the coordinates of this point would be? And what do you think the coordinates would be down here? And what do you think the coordinates would be in the fourth quadrant? We're still going to use x and y, but let's think about the signs. This is a positive x. This way, it's a negative x, but it's still a plus y. How about down here? We have a positive x, and we have a negative y now down here, right? And then the r will still be the same. This one here, let's draw them all in, right? This one down here, well, that's a negative x, and it's also a negative y, right? This is a negative y down here, that's a positive y, and these are all r. So the idea is that you have 4 exactly the same triangles in each quadrant. And what's going to happen is that we're going to see how your sine, cosine, and tangent repeat in every quadrant because your y and your x are the same in each one, and your r. So that's kind of going to be the next step, okay? Let's look at a few examples. I'll try and draw some ones that make sense here for you. If I gave you an angle of, let's say, 135 degrees, where would you draw? I'm going to ask you for the reference angle. Would you know where to draw that? Well, if we know that this is 0, and that's 90, and that's 180, we have to find the reference angle. We know it's between 90 and 180. Well, from 90 to 135 is 45 degrees, right? And from 180 to 35 is 45 degrees as well. So what we've got here, this is 135 degrees. From here to here is 135 degrees. That would be your angle in standard position, okay? And down here, your reference angle would be 180 minus 35, which is 45 degrees. Okay? And we'll leave it at that, and we'll cover any more questions that you have next day in class.